Hi, chemistry students. I actually have a couple more examples from 7.2 ionic. So this should be the word form. Just notice the mistake right here. More examples of doing ionic bonds in the Lewis dot. So we said oxygen had 6 valence electrons and lithium had 2. We drew 1. We drew 2 of them because of the formula. 2 lithiums, 1 oxygen. Now, the rule that we use is we want valence electrons. We want 8 valence electrons. And I say or bust, or we want none. So what happens here is lithium transfers its electrons. When it loses that electron, when it loses an electron, a negative times a negative, it becomes positive, and we have this lithium ion. Then we have oxygen. It got these 2 valence electrons, so it has its octet. Because it gained electrons, it is an ion with a charge of 2, and then our final lithium here with a charge of positive like the other one. So this is what the final Lewis dot diagram of this ionic compound is. I'm going to do a couple more with you. Next up I have AlCl3. Okay, so here we have a metal and a nonmetal. That means it is ionic, cation and anion. So I have aluminum is probably going to be in the middle. Aluminum has 3 valence electrons. Okay, then I have chlorine. Oh, I wanted a different color for that. Let's see if this will be a different color now. There we go. Chlorine, and chlorine has 7. Sorry if I'm following the pattern, it should go like this. Okay, I have, oops, one too many. Another chlorine. And a third chlorine. Okay, so they all want 8 or nothing. Well, look, if this aluminum came there, if it moved, rather, and if this one moved there, and finally if this one moves here. So what we would have then is we would have a chlorine with all 8. It gained an electron. Because it gained an electron, it is a negative cation. Then we have aluminum with no valence electrons. It gave them all away. It gave 3 away. Then we have chlorine with all 8. And one more chlorine with all 8. And it is negatively charged. Why are these 3 around aluminum? Well, we have a positive and negative, and there's some electrostatic forces happening there. One more. Sodium and chlorine. Well, we just finished saying chlorine had 7 valence electrons. Sodium has 1. Well, guess what's going to happen? Na is going to transfer. When it loses an electron, it becomes negatively charged. It has no more valences. Chlorine has all 8 now because it gained an electron. Sorry, this is a positive because it lost an electron, and this is a negative. We don't have to put that 1. We could just write negative. It's assumed. It's 1. Okay, so this is what the final, Lewis dot looks like. Now we're going to move on to 8.1. Just want to see if I have, good, I have my chemistry opening. So we're finding all this, of course, in this section right here. I'm just going to open it. We might start hearing about salt water because I don't know how to turn that off. Good. Eventually we're going to have to come to
Let's
here.
add a small amount of table salt, sodium chloride, to water. As you know, sodium
I was going to
chloride
just keep
dissolves in
talking for
water.
a bit. A quick review. Period is another word for the row on the periodic tables. Rows
Click on the zoom button
on
to view
periodic
sodium
table.
chloride dissolving in water on a microscopic scale.
And you should have seen in the video about the crash course in chemistry and the periodic law, we have repeating patterns. It's every 8 it repeats. Okay. Group is the column on the periodic table. Okay. And the group have all similar properties. One of those are that they have the same valence electrons. Okay. Ionic bond, we just said, was a transfer of electrons. Okay, what else did we say about ionic bonds? And it is a attraction between a cation, I like cats, and an anion. I don't like onions. So we have that attraction there. Okay. These are also, the cation is a metal, the anion is a non-metal. Covalent bond between two nonmetals. The electrons are not fully possessed by a single atom. Okay. Electronegativity is an atom's tendency to attract and form bonds with electrons. Okay, as we go across the period, increase from left to right, we increase electronegativity. And the group, or the column, as we go down the column, we decrease electronegativity. Okay, so some examples. HCl. Well, these are two nonmetals. So we have hydrogen with 1 valence electrons, and we have chlorine with 7. Now, hydrogen would like 2 valence electrons, that's its full, and chlorine would like 8. So if we shared these 2 electrons, if they were between them so that neither of them really owned it, but it was a sharing, everyone would have the amount that they wanted. And what we do, instead of writing it in this way, To show that electrons are shared, or to show that they're bonded there, we put a line. And that line represents 2 electrons. This is the covalent bonds. Right there is the covalent bond. Okay, let's try another one. H2O. Well, looks like we have H2O. We're going to put oxygen in the middle. It has 6. And then we have hydrogen with 1. Look, these guys are going to share those. And that's going to share as well. So we have H, single bond, oxygen, single bond, hydrogen. Each of those lines represents 2 electrons. Okay. So the rest of the sheet, it asks you for the rules that you're going to follow. And where you find those rules is on the course. Oops, wrong course. You guys are not taking chemistry. You guys are taking, what just happened here? I wonder if it's hidden. There we go. There's chemistry. You're going to go on the course, and there's a little spot right here. And it says an interactive lesson on covalent bonding. You're going to click on that. Hopefully it opens up for you. It goes through a lesson. I want you to read all the way along. It talks about different parts of bonding, covalent bonding. We see some diagrams. It asks you some questions about how many valence electrons things have. And then it's going to give you a set of rules for making the diagrams, and it's going to give you some good examples of diagrams. Okay, once you've done those good examples of diagrams, I want to make sure that you, first of all, you write those 6 rules. There are 2 exceptions, and those are boron and phosphorus. And it actually goes through and explains what the difference is. So as you're going through the simulation, I want you to write down the rules and a couple of good examples. Once that's done, you have an assignment where you have to write Lewis dot diagrams for both ionic and covalent molecules. And yeah, you also have to name them. So that's some retrieval either from your Chem 20 or your Physical Science 20.